This session is called Everything You Need to Know About Feature Layers in the ArcGIS API 4.x for JavaScript. So my name is Noah Sager. I'm a product engineer on the JavaScript team. And here with me is...
Yeah, I'm Jan Cabon. I'm a lead developer on the JavaScript API. We decided to do this year because I think there is a lot to cover in each layer. So we wanted to to do a series of 3 demo theaters. This is the first one. Right after we have OGC layers, and then tomorrow we will have map image layer. Depending of how you like it, there is a lot to cover. So I think we're gonna just scratch the surface, but of each individual feature. But if depending of how you like or dislike it, we might just transform this to a full-fledged session, longer session next year.
Cool.
So yeah,
All right, and then just so you know, all these presentations, the demos are going to be on GitHub. If you want to snap a quick picture, that's the URL, or you can come find us at the product island. We can give you the URL, and it'll also be in the proceedings after the conference. So you can see the presentation, the demos, all that good stuff. Share it with your friends.
Just take some time.
All right, we'll go ahead and get started. So, feature layers. So we'll start off with a brief introduction. Feature layers can be created from 3 different sources. One from a service URL, from an ArcGIS portal item ID, and that means ArcGIS Online or portal for ArcGIS, or from an array of client-side graphics. So we'll go ahead and take a look at what a feature layer looks like. These are simple points on a map that have been rendered, showing trees at Warren Wilson College in North Carolina. And if we go ahead and take a look at the code, it's really simple. You're bringing in one required module, one Esri layer's feature layer, and you create a new layer and assign a URL, and then you add that layer to the map. Very straightforward. Another way to do it is to reference a portal item ID. In that instance, you'll create in the feature layer constructor, you'll have a portal item property, which autocasts as a new portal item, and then you assign it the ID, and then you add that layer to the map.
So the benefit of using the IDs is if you go to ArcGIS Online or on the portal, you can create a portal, you add your layer and then you save that as an item. And all the configurations that you're going to do on your layer is going to be saved into that item. So then when we get the ID, we get the URL of the service to ask for the features, but also the renderer, the opacity, the scale range you might set, the labeling info, and so on. So it's a very convenient way. You may have people in your organization that just configures the data and the maps, and then us, we just have to, as developers, we just consume everything already configured. So,
yeah. Awesome, that's a great point. The last way to do it is from an array of client-side graphics. So here we have a new feature layer, and we have some properties we're going to create. A few required fields are item ID or object ID. And then we also have a type and a place field. You also need a geometry type because you can only have one geometry type per feature layer. So this one's a point. And then you need a spatial reference, and then you assign the source. In this case, it'll be graphics. Here we also have a pop-up template and a renderer. And then you just add a layer to the map, the same as you did if it was from a portal item, and the same as from a service URL. All right, so let's take a look at labeling. So at 4.x, obviously 3D is a big deal. And I should step back. We're going to show a bunch of examples from 2D and 3D. The same principles are going to apply to both, with the exception here, labeling is currently only supported in 3D with the feature layer. We're going to have support for 2D. We're working on it now, and that'll be at a subsequent release. But creating an actual label for your feature label is very straightforward. You create a label class, and then you have a symbol, you give it a type, here it's label 3D, and then you have a symbol layer and you call that text, which will autocast as a text symbol 3D layer. We're going to make that white, as we saw in the sample, and the font will be size 10. Then we have a label placement, we'll do above the feature and to the right, and then we have an expression to show what field to actually render the label on. All right, so now we were talking about rendering, so we can dive into that. So if you're unfamiliar, rendering is a way to apply a set of rules to show how your feature data will be symbolized. So here we're going to use a manual visualization to create our render. So this is a very straightforward example showing 3 different types of road. They're separated by classes and applying a separate render to each. What Jan said earlier about consuming a portal item, this could have been configured in ArcGIS Online or in Portal, and you would just consume it with this styling already, or you can define the rendering in the code itself. So we can go and take a look at what that code looks like. So we're going to create a variable called highway render. It's going to be of type unique value. We'll have a default symbology that's going to be used for all features that don't fall into the categories we're going to assign. The field's going to be based on its class. That's the class of road. Then we'll have our unique value infos, in which here we define what the render should look like for each class. So the first one is value I for interstate highways. We're going to assign the symbol we use for it and give it the label interstate. For the US highways, that'll be value U, and these values are coming from the data itself. So we look at the data, we tell what's in there, and then that's how we visualize it. And we assign that symbology between highway symbol, and then we label that US highway. So I'm not showing you the actual symbols, that's in the sample as well, but this is just what the render looks like to visualize it manually. Okay, visual variables. So visual variables are a great way if you have numeric data and you want to symbolize it on the map, but you want to have a continuous ramp. And that can be used for color, size, opacity, or rotation. So if you want to do, say, thematic mapping and you want to tell a really powerful story, visual variables are great for that. Or if you want to show the realistic values of your variables, visual variables are good for that as well.
Just something. So it's an addition, it's a property on the renderer. It's like you configure your simple renderer or your unique value renderer. So first we will, if it's a class break renderer or a unique value renderer, we'll pick the correct symbol for your feature. And then we apply, interpolate kind of like the size between, you're gonna show that, but we will, it's modification on the symbol that you configure on your renderer.
Awesome. So let's look at an example of that. So here we have one feature layer. It's being visualized based on the color and on the size. And this time I'm going to dive into the developer tools and show you what it actually looks like. So if I go to source. Okay. So in this sample here, we have a pop-up layer. So here are the visual variables. So I'm going to create a variable called colorVisVar. I'm going to assign it to be a type color. Remember I said before, it can be color, it can be size, opacity, rotation. This is the field that it's going to pull from, that it's going to symbolize based on. This is the normalization field, which is the total population. Then I'm going to assign some stops. So Jan talked about interpolating the data. I'm going to assign a minimum value and a maximum value and the colors that I want for the min and the max. And the visual variable is going to handle the rest. It's actually going to interpolate all the values that fall between those two and assign it a logical color based on the colors I set for min and max.
So here in this case, the value for each feature, it's going to be the field, that field divided by the total population. And you get something normalized between, I guess, 0 and 1. And so, yeah, we interpolate those. So all the values that are below 0.33 will have that color. All the values that are above 0.53 will have the second color, and then everything in between will be interpolated.
So the way you actually use it is, here we're creating the size visual variable because we're using 2 in this one. So this is of type size, the other one was of type color. This is the field we're going to use, and again, we're going to normalize it. We'll divide it by the area. And because this is actually going to be population, the value unit here is unknown. And then similar stops. We'll have the minimum value be 4,000. That size will be 6. And as Jan was saying, anything below 4,000 will default to 6. And the maximum value will be 23,000, which will be size 40. Anything above 23,000 will default to size 40. So we have 2 visual variables, and now we're going to consume them in the renderer. So here's our renderer. It's going to be a simple renderer. We're going to assign a symbol. It's going to be a simple marker symbol with a color and an outline. And we give it a label, and then we have a visual variables parameter where we pass in an array of visual variables. So we could have, once again, color, size, opacity, rotation. Here we're using those 2. And once we have our renderer defined, we simply add it to the layer. This is actually the constructor for the feature layer. And we have the URL, we have the title, we have all that stuff, and then we just pass in the value of the renderer to the renderer property on the feature layer. And then we add that to the map, and it takes care of everything else. Okay. And so this is what I just showed you before with the visual variables. So what goes along nicely with that is something called smart mapping. So this has been a big thing for the 4.x version of the API and ArcGIS Online. This is a way to, if you have some data and you have a base map that you want to use, but you don't know what the best color scheme is, we have a way of actually helping you visualize that the best way that we think based on all the millions or billions of maps that Esri's created over the years. So there's a lot of information that's gone into this. So in this case, we're using smart mapping for the size of the features. So the color we're leaving is that default orange, but the size is actually going to come into play here. And we have a slider that I can actually interact with the map, and I can change the min value and the max value, and it's going to visualize all the features based on my stops. So that's the minimum value and the maximum value.
So under the hood, the smart mapping asks the service about statistics about the field that you want to visualize. So if you are in ArcGIS Online, in the map viewer, on Portal or ArcGIS Online, you pick the fields that you want to visualize, and then automatically we ask for statistics about like what is the standard deviation, the average, and so on. So we pick the best default values for the visual variables that we just showed you, and then after we can further customize those values.
So this is the size visual variable. We pass in the layer. We tell it the type of base map we're going to use and the field of interest. And then we have the normalization field. We give it some legend options. This is going to be setting up that slider that I was showing you before, so you can interact with the map. And then this is where we actually create the renderer. We use a size renderer creator, and we pass in that visual variable that we made earlier. And then we just apply that renderer to the layer and then add it to the map. So you see we have a very similar pattern where we create the renderer, apply the renderer to the layer, add the layer to the map.
Yeah. So going back a little bit on the different parameters. So the field. So here we want to visualize the poverty, the population poverty over the total population. So we pass the field and normalization field. So as before, but then now we pass the base maps because Esri has curated all those different base maps, light gray, dark gray, imagery, and for those base maps, they will curate the best colors that we think fits for colorblind people, for everyone like as a good look. So by passing the base map, you get the best color ramp, for example, that fits that base map. There are other options, like you can pass a theme, like if you want to have like a low to high or high to low or centered on, it would give you a different configuration of the color visual variable or the size visual variable in that case.
All right, so with that, I'm going to pass it back to Jan. He's going to show us editing.
So what's interesting with the feature layer is that it's directly connected to the database. So every time you start up your application, it will fetch the features directly from the database, right? So feature layer originally was created to be able to edit the data. Oops, sorry, I come back. So we have a sample. Most of the examples that we show here are samples from the SDK. So you will be able to directly see the code in more details and so on. So this is one of the samples where we show a simple editing app to report accidents. So as you can see, like the sample starts here, so everyone edits in that region. So here I'm going just over like the campus of Esri, and then I can add a feature, and we can see that the feature is added. What just happened is that we made a call to the feature service to say, hey, I'm gonna add an accident here, and then after I can add some description and contact. So what other things we can do is updating. So I just added an accident and updated the attributes, and now if I come back, my incident is here, and then I have the correct description. I can change it, and so on, and we can also delete it. So that's the basic of editing, and normally my feature is gone. So to do this, we call the ApplyEdit. So here, like this is extracted from the sample, but ApplyEdit is called FeatureLayer ApplyEdit. it's a method on the feature layer, and we pass an object with 3 parameters. They are optional. So one is update features, but you have add features and remove features, delete features, sorry. And it's an array of feature objects. So it's a graphic with the geometry and attributes. And then we send that to the server, and then it updates on the database. Right. So querying, so that's the other part. So editing is the advanced case, but querying is necessary for us to display. So every time, if we look at the, so this is this one. If we look at the network tab, the way it works, yep. So we can see that when the application starts, we have multiple features displayed on the screen, and we see multiple queries going on. So it's a URL with different parameters. So we have like the fields that we require, and then a where clause. So in this case, it has a definition expression. So we can filter the features we want to see. Oops. And then in return, we get a feature set. So it has the different features. So in this case, it has like more than 2,000 features, like around 2,000 features, 2,000 features actually. And so each are the geometry and the attributes, right? So because we ask for all the attributes, we have everything that is in the database, in the table, I mean. Okay, so then after you can query yourself the layer. So in this example, we have, so it's one of the sample also of the SDK. We do a buffer around multiple points, and then what we want is to query for earthquakes that happen into that buffer. So I have my little button, and then when I query, I get all the earthquakes that happen here, and then I can do further filtering. Like for example, if I want to have all the earthquakes that are more of 4.2 magnitude, I have 2 of them. So this one I show the code, right? Oh no, it's after. Sorry. Up. So what we did is we created a query, and then we just call query features. So this is the first part. Oops. Oh, it's not what I wanted to show. Sorry. Coming back here. Source. Right. So every time I click on the feature on my button here, I will call query earthquakes. So what we do is that we have a convenient method on the feature layer, so the quakes layer is a feature layer. It's called create query, and it will create a default query objects with the different options that are available on the layer by default, and then we can override what we need for our example. So here we want to just get all the earthquakes with a magnitude greater than the value on my slider. So I will create a where clause with the magnitude greater or equal, and then the value. And then we want to also filter spatially the features we get back. So we will specify 2 parameters. One is the geometry. So we want to have all the features that are in that buffer, and we'll specify the spatial relationship to intersect. And then we query the features. So this returns a promise here that then when we will get back the response, we have this second method called display results. So we get our results from the service. It's a feature set with features, and then for each feature we get the feature and we will assign it a symbol. And this is what we see here. So it's an orange symbol. Color dark orange, a size of 6.5 points. And then we add all the features to our result layer to display the result of the query. Okay, what works in 2D also works in 3D. So in this case, we have a scene layer of buildings, and then when we click on one of the buildings, we ask another service for more information about the building we clicked on. Okay. Huh? Oh, that's the one on view, sorry. Yes. Okay, so something new, if you are familiar with 3x, when you call query features on the layer, it will try to be clever. It's clever about like knowing if it has the features already downloaded on the client or if it needs to go and ask the service, right? Sometimes it's very good because like that we avoid like a round trip to the service, but sometimes we want to have more control about it. So this is actually what we are doing here. I was mistaken. So if we look at the source code, so we have two ways of querying in the 4x API. Either you will use the query methods on the feature layer, or you will use it on the layer view. So in this case, I want to have the layer view. The layer view in 4x is what displays the layer. So what draws the layer on the screen. So imagine that you have two map views. We have that example later, right? The two map views. If you have like two map views that that displays the same map, they may be in two different projections. So one will ask the data in the first projection, the other one in the second projection. So the layer is the same, it's the same point, it's the same service, but then the view is different. So we ask, what is the layer view for that particular scene layer that we have here? And then when we get the view, we will create a query and execute the query on the scene layer view. And this query is not, so we ask for the extent of the result. And what is going to happen here is that all the query is evaluated client side. It's not going back to the service. So if we don't have the feature on the client already in the web browser, then you will not get any result. You will only get what is already downloaded. So you have more control about, do I want to ask the service or do I want to interact with what is displayed on the screen? Okay. This was that. So when a feature layer is displayed in a 3D environment, you can use 3D symbology. So you can use the same symbols as in 2D, like simple marker symbol, picture marker symbol, and so on. But you have also other type of symbols, like those realistic trees. They are called, the name for that is Webstyle Symbols. You know, because you can't really author that by hand, like it's quite complicated. So, so we provide a set of, so it's called a Webstyle symbol. You assign that as a symbol on your renderer, and like anything. But then you assign it a unique key, a string, to say, okay, I want to display a bench, I want to display an ambulance, and we have a full catalog of symbols for you. So in the SDK, if you look for a Webstyle symbol, you will get, you will have a guide page, a link to the guide page of all the different symbols that are available for you, and they are classified by different themes. So we have basic shapes, we have thematic vegetation. So for example, for those, so thematic vegetations are trees, like for example, American chestnut, and that has this shape. And all of those also can be affected, for example, in size by the visual variables. So we have all sorts of trees, and we have like vehicles, vegetation, and so on. To create one Webstyle symbol, let's go back. To create Webstyle symbol, it's very simple. You can just define your symbol like this. It's of type Webstyle, and then the type of the category basically of symbols that you want to display. So thematic shapes in this case, and then I want to have the standing diamond. So all those different combinations of keys are available in that first page I show you. So in this case, the tree, if we look at this one, sorry? Okay, but that's fine. I can show the how it was configured. So in this visualization, we have different visual variables that are affecting different parts of the trees. So we have defined our renderer. It's a simple renderer because it only has one symbol. It's a realistic tree style, and then it's type other. So any, like a generic species, I guess. And then we have different visual variables that are configured. One is the size we want to affect the size of our symbol. So it's based on the field that is called height. And then in this case, we specify a value unit because we know that in our service, the height is actually represented in feet. So we actually represent at the correct scale the symbol. And then we also affect the width of our tree and basically the three axes of the tree. And then now we will modify the color based on the carbon storage of each of those trees. And so same as before, 2 values and then 2 colors. So it's pretty nice in the end. Okay. So this was the 3D symbology, website symbol, and pop-ups. So this one is pop-ups. So one of the big advantages also of the feature layer is that you can define a pop-up template. So it's a very simple object literal here, and you can define a title and a content. The title, you can reference a field directly if you put the curly braces. So when I click, just by defining that title, I get the species, which is American sycamore, white oak, and so on. And then the content is some like simple HTML in this case, and then there are multiple combinations. We detailed that in the SDK, but in this case, I just want to have I would have like the scientific name of my tree as well as a description that I write. So this tree is in field condition, so it's good condition, and then we display the height of our tree. Same if you go on ArcGIS Online and if you configure your pop-up, then when you load the layer by ID, you get all this information already pre-configured. Okay. And so something we are working on is using, so in 3D, everything is displayed using WebGL, but in 2D we are working on like we are re-engineering under the hood all the display to use WebGL. So this example is without using WebGL. It takes a bit more time, it takes some time to load, and then one of the features we don't have in SVG yet is highlight. So when we click on when we hover a county here, there is nothing indicating that we are hovering the layer. So if you activate the WebGL code, we have to add this as flag, which is like a feature flag for the mode using WebGL. So you say Esri feature layer WebGL, and then it's gonna go and like load the layer also the same way, but then it's gonna use WebGL. And one of the benefits we have is we can display more data. In this one doesn't really represent that, but one of the advantages is that we have a nice highlight when we hover the features to get those information. In general, the WebGL also allows us to display more content than SVG. All right. Oh yeah. So this sample also is very interesting because it displays a same map with the same feature layer, but then in 3 different map views. So we have this global big map views for the continuous USA, and then we have a second map view with a projection over Alaska, and then another one over Hawaii. And in the same map, you can see like all the United States, I guess. So that's pretty cool. All right, and that concludes our presentations. So if you have any questions, we can take a few minutes. Yes. Yes. So what can we not do? Yeah. What can we not? The question is, what can we not do yet in 4x that we can do in 3x? We don't have the support for all the renderers. We are working on a heat map for 2D, and then we are missing also temporal rendering. So if you have a time-enabled feature layer, yeah, we don't yet support it. It's in the work. We are missing labeling in 2D. We are working on that. We were a little bit short to show it at Dev Summit, but you're going to have some news about it for UC. Let me think. I think it's pretty much it. Dot density renderer also, there will be a demo of dot density using WebGL on Friday at the Roderhead session for JavaScript. Yeah. Sorry? Does labeling support multi-line? I don't want to tell you because I'm not sure. But for 2D, we are working to get the multi-line rendering because we don't have that in 3x. It's really painful. So we are working like with that in mind. But for 3D, I don't know. You would have to ask some of our colleagues on the island that are specialized on the 3D aspects. Yeah. So yeah. They are the API promises, yeah. Oh, no. So the promises, when you do a query, for example, it's an actual promise. Yeah, we changed for the layers the .when. We introduced that last release. So. But when you do querying, you don't have to worry about the Esri promise stuff. That is only on layer. It's only for layer. For all on the layer instance. But for the query method, it's still regular promises. I can deep dive into that problem if you want to ask me the question. I can explain why we had to do that. Yeah.
Okay, I think that's all the time we have.
Okay,
sorry. We're going to be done with FeatureLayer. We're going to move on to OGC. But if you have more questions, we'll be here after that. And we'll also be at the Developer Island. We'd be happy to chat with you. So thank you all for your time.